Welcome everyone. My name is Andrzej Bialecki. I'm going to talk about components for Sidecar index management in Solr. I'm one of these guys who started using Lucene quite a while ago. That's actually 10 years ago. Pretty quickly I realized that I really wanted to know how Lucene stores different kinds of data. So I created this utility, which is called Look, Lucene Index Toolbox. I'm involved in several open source projects like Notch, Hadoop, and obviously Solr and Lucene. And I'm currently working as a LucidWorks engineer, working on the LucidWorks search platform. So I'm going to talk today about the challenge that we are all facing, all implementers of search applications, which is how to handle incremental updates to your index. I'm going to briefly cover existing solutions, or more like workarounds and not real solutions. And then I'm going to present yet another workaround that we came up with at LucidWorks, which is this sidecar index strategy. So what is the challenge? In many applications, you would like to, especially people who are familiar with SQL databases, you would like to say, okay, update this field in that document, and to do it for like 1 million documents. Because you just need to flip a Boolean flag in all of these documents. This should be easy, right? And it's a pretty useful functionality, isn't it? So it may be surprising that Solr and Lucene don't really support this functionality yet. And they haven't supported it for the last 10 years. So if you say update in Lucene, what you're really saying is that, okay, I'm going to retrieve the old document. I'm going to update this in place using either Lucene document or Solr document. And then I'm going to add this document and as a new document to the index and delete the old one. So every time you want to update this little Boolean flag in 1 million documents, you have to do this little dance with every document. There is a functionality in Solr that tries to sweeten the deal, so to speak, which is called atomic update. But it's just a syntactic sugar. What it really does under the hood is it still performs this little dance, retrieving the old document, updating the field, and adding a new document and deleting the old one. Only it happens on the server side so that the clients don't have to deal with it. What are the common use cases? I think there's some feedback from the microphone. Okay, thanks. Can you hear me well in the back? Okay, great. So what are some common use cases for field level updates? Well, if you have documents that logically consist of two different parts, like you have the main content and then you want to just update some bit of metadata in the document, like a Boolean flag or the popularity or whether the item is in stock or stuff like that, then you're facing this problem. And you could divide this challenge into two parts, or two use cases. One use case is if you want to update numeric fields, like popularity, in stock, or some promo campaign, or some other numeric value. And the other part of this problem, more complicated problem, as you can guess, is to update full text fields. Text that need to be searchable, like, for example, customer reviews or some tags or labels that you want to put on documents which need to be searchable. Or if you collect click-through feedback, I'm going to talk about this a little bit more later. Or if you want to index user profiles. All of these scenarios require that you have to update pretty frequently parts of the documents that need to be also searchable, full text searchable. So the challenge is how to integrate these relatively minor modifications with the main index, which may not be changing so frequently or changing at a different pace than these updates. Reindexing the whole thing all the time isn't always an option, right? So it's loading something, but I didn't click anything, so I don't know what that is. Let's click it away. Go. No, I don't want to speed up. I'm already up to speed. Sorry. Quit. Yeah. That's why I switched to Mac, sorry. All right, first the bad news. The true field level updates for full text searchable fields are still not there in Lucene. This is really a very complex issue, and partially it has to do with the organization of this inverted data in the index. It's simply not optimized for these partial updates. So that's why there were several attempts to implement this, but this is still pretty much a work in progress. There have been some progress made, so it's not completely left alone. But I would estimate that if people who started working on this put some effort into it finally, or more effort than recently, then this feature is still like 6 to 12 months away. You can check the progress. There's this Jira issue, 4258, and related Jiras. So that's the bad news. Sorry, true field level updates for searchable fields are not there yet. So how to handle these updates? Well, as I said, reindexing everything is not always an option, but there may be cases when this is an option. So you should not shy away from these situations. Sometimes if your whole collection of documents is like 100,000 documents with pretty simple structure, why not just reindex everything? It could take, Solr and Lucene is pretty fast at indexing. So if your indexing job takes 5 minutes, then let's not complicate and over-engineer things, right? Let's just reindex everything. So the advantage of this approach is that it's, of course, trivial to implement. You just update the source of this data and reindex everything. And you can add and modify any type of data. Basically, you are recreating the content of the index. There are some disadvantages too, unfortunately. If you have a larger corpus, if you have several million documents and you use complex analysis chains, maybe you are doing named entity recognition or parts of speech tagging or some other stuff or lookup in external databases, well, this, of course, quickly becomes infeasible, time-wise and cost-wise. And another aspect of this is that it requires that you keep the source of all documents, right? The source data has to be kept somewhere. And this is not always convenient, especially if the source data doesn't come from a single particular source, but instead it's assembled via a complex pipeline. You can handle some of these scenarios mostly with numeric updates using Solr's ExternalFileField. This is, again, very simple functionality to use. You basically put a text file that specifies for document ID doc0, this field value will be 1.5, and it's a floating point number. So couldn't be simple, right? You just edit a text file and just reload, refresh this structure in Solr, and off you go. The limitations are obvious. Well, this is not a full text field, right? It's a purely numeric field. So it's good for updating information like popularity or in stock, but of course it doesn't handle full text fields. So you cannot use this functionality to, for example, attach searchable labels to documents. Sorry. Still, it's quite useful. Internally, it's implemented as an in-memory value source, so it loads this whole stuff in memory. So again, if you have many documents, this may have some impact on memory. Numeric doc values updates. It's a feature that was, I don't know if Shai is here. Yeah, congratulations and kudos to you. give a round of applause for the man, because this is a very, very useful functionality. It's not advertised yet because it will be released in Lucene 4.6. But it's really, really handy because it's a very elegant way of handling these numeric updates, which you could handle with external file field, but this is much more elegant. So on the API level, it's as simple as invoking indexWriter update numeric doc value, and using a term, you can select either one document or multiple documents, right? And then you specify the fields where the update should be performed, and the value, like a long number, right? The new value that should be recorded. So, as I said, it's a very new feature, but fortunately it was backported to Lucene 4. So really, really soon everyone can use it, and I predict that there will be, a whole new class of applications that will become possible just of this single feature. So you should take a close look at this functionality. There are, of course, some limitations. One most obvious limitation is that it still deals with numeric updates only. So before I cover the main topic of this talk, I would like to refresh your memory a little bit on this somewhat obscure class in Lucene, which is called Parallel Reader. Parallel Reader is a subclass of index reader that treats two or more existing indexes exposed via index readers as vertical slices of a single larger index. So as you can see on this picture here, let's say that we have the main index reader here on the left side, which has some internal structure, right? And it has field 1 and field 2, some set of fields. And then we have another index with exactly the same structure that contains a disjoint set of fields, field 3, field 4, etc., etc. So what parallel index does, it sort of combines the data from these fields on the fly and presents a complete picture that contains all the fields, which is the stuff on the top, right? And both stored and inverted parts are supported. So this means that we can handle the full text searchable fields, right? However, the structure of these two or more indexes must match exactly one-to-one. What it means is that these indexes have to have the same number of segments. The number of documents in each segment have to be exactly the same. And of course, the information recorded for particular IDs, internal IDs in each segment, has to match one-to-one. Otherwise, you will get portions of different documents, right? And the list of deletions, if there are any deleted documents in the first index, is taken from the first index. So this sounds really cool, right? But in practice, this class is very rarely used. Why? Well, it's simply almost impossible to meet these requirements, especially with the index that is actively being updated. You have merges going on, so the number and composition of your segments keeps changing, and new segments are being added, so it's hard to keep up with the structure of this parallel index so that it still matches one-to-one with the main index, right? Are there any questions so far to this part? No? Okay. Great. So, as I said, sooner or later, if you don't handle these updates very carefully, you end up with the situation that is pictured here, that your secondary or ternary index gets out of sync and has a different composition and different structure, and then, of course, parallel reader refuses to work. So that's the disadvantage of a major pain point of using this class, that the structure of these indexes must be exactly the same at all times. And unfortunately, there were no tools to manage this kind of parallel indexing in Solr. And this is altogether a very complicated and fragile structure. So the thing that I've been working on for the last several months was a suite of components for Solr that can handle this parallel indexing. The question was, why do we want to have this parallel index? Let's go back to this slide. Well, as you remember, we are facing the challenge of having two different sets of fields in the documents, or two different parts of every document that are updated under different schedules. So we have the main content. Let's say we have the body of the document that we have indexed, and then we have a set of metadata that is changing at a different schedule. Let's say it could change overnight, right? And then we don't want to reprocess every document from scratch. We would just like to update a part of this document. Okay? So these sidecar index components for Solr, it's a collection of classes, components for Solr that use this parallel reader strategy for implementing partial updates. So these components work with the main and sidecar parts of the data, which comes from two different Solr collections. The sidecar collection is updated independently from the main collection, right? And the sidecar collection is used as a source of some of the fields that end up being sort of synthetically attached to the fields that are present already in the main collection. So these components integrate the management of this parallel reader with Solr. So they handle the initial creation of this parallel index, including the synchronization of internal IDs and synchronization of the structure of the index. And they also handle track the updates to the main index and react by updating the structure of this parallel index. This particular implementation is partly based on the implementation that we've done at LucidWorks to implement the integration of click-through feedback with the main index. I'm going to talk about this a little bit later. And the code is for these components is available under Apache license on GitHub. I believe the slides will be available later on, so you can just check this link later. You may wonder about the name, right? As you all probably well know, every complicated IT concept has its own car analogy, right? So you can often hear people saying, "Oh, why did you do this? It's like buying a Ferrari and putting a Ford Fiesta engine in it," right? So that's what we often hear. I wanted to break with this tradition and use a motorbike analogy. So here we have our main index, right? Fine guy who knows what he's doing and has, his own concerns. And here we have the sidecar person that has her own concerns and her own mind, and there is a tension between the two, right? Oh, why didn't you turn left when I told you? Well, never mind. So at some point, of course, analogies break, right? But that's the history of the name. The sidecar is this additional data that is at a certain tension or in addition to the main data. So on a high conceptual level, this is quite simple. We have the main collection that contains only the parts of documents with main fields. And we have the sidecar collection, which is the source of these additional sidecar fields. And then there is a component in Solr, which is called Index Reader Factory, that actually knows how to open Index Reader on a given index. And this sidecar Index Reader Factory creates and maintains this ensemble of the main index and this parallel index, the sidecar index. So the main index is updated as usual, And the magic of this sidecar index reader factory knows how to update this sidecar index with the data coming from the sidecar collection. On the implementation level, things, of course, become more complicated. As I mentioned, this index reader factory and the implementation sidecar index reader factory has two methods. One which handles the initial opening of index reader, and the other one that uses this internal buffer or internal snapshots of documents that are not yet committed to disk from index writer for near real-time reopens. So this index reader factory has to handle both cases, the initial opening and initial building of this sidecar index, and then it has to react to updates as new documents are being added to the main index. Implementation-wise, the sidecar index reader, I would love this implementation to be a subclass of parallel reader. Unfortunately, it's not possible because Solr really insists on using a directory reader. And as it turns out, parallel reader is not a subclass of directory reader. So we had to more or less copy and paste much of the implementation of parallel reader to this sidecar index reader implementation. So how do we address these several challenges, right? First of all, we have to synchronize the internal IDs of documents between these two indexes. Then we have to shape this parallel index so that its shape, its internal composition, follows closely, or actually is identical to the shape, the number of segments and number of docs per segment, etc., for the main index. How to handle deleted documents, how to handle updates and merges in the main index, and how to handle updates to the sidecar collection. So let's take a look at this. First of all, let's start with the initial creation of this parallel, this sidecar index. How to synchronize the internal IDs? Well, it's sort of a brute force approach. When this new reader event is first encountered, we open the main reader, the main index reader, and then this component simply traverses linearly all data in the main reader, main index reader, retrieving the primary key, and does a quick lookup, and primary key lookups are really quick in Lucene, does a primary key lookup on this sidecar collection, and retrieves the document that matches that key, right? And then it adds this document sequentially to this sidecar index. So here you see we started from document number 0, which has a key D for some reason. It's not guaranteed to be in alphabetical order, right? And then we do a quick lookup in the sidecar collection, and we retrieve the document with additional fields that has the same primary key. And then we add this to the sidecar index here. Of course, as you can expect, this is a very costly phase. Basically, we have to do a random search for every document in the primary collection, a random search on this sidecar collection. So it's a very costly phase. Fortunately, primary key lookup is very fast. Still, stored field retrieval and then indexing those fields in the sidecar index still has some cost. But we can optimize, and also we can cheat a little bit. So one optimization comes from the fact that Lucene, once Lucene created a segment, this segment basically is immutable. So if the composition of the main index still consists of these indexes, of these segments that are numbered 0, 1, 2, 3, 5, for example, then we don't have to scan again documents that correspond to these segments if we already have built the parallel segments that match one-to-one to these existing segments, right? So that's why these segments in the sidecar index are grayed out. We don't rebuild them. We just rebuild the data that corresponds to the newly created segments. Optimization number 2 is more more like cheating. We ignore near real-time segments. So for near real-time segments that are still in memory, they haven't been flushed to the disk, we're just saying, well, sorry, there is no sidecar data for these documents. You have to live with it. What it does, it saves a lot on these lookups and indexing for partially created segments that keep changing quickly in memory. The next question was, what do we do about deleted documents? Well, of course, because internally, Lucene numbers documents sequentially, like from 0 to n to max doc. Then we have to preserve this numbering, this internal numbering. So if there is no corresponding document, either in the sidecar index or in the primary index because it has been deleted or marked as deleted, then we just add a dummy document, just to keep track of these increasing document numbers and to keep in sync the size of these segments. The next challenge was how to create segments that are exactly alike the segments in the main index. Well, the answer is we do it carefully. So we have to be very careful about how we construct this sidecar index. The index writer that is writing to the sidecar index needs to use a serial merge scheduler so that there are no merges that merge non-adjacent segments. And then we of course have to keep track of the number of documents per each of these segments, so that after the final merge, we get a segment that has the right composition. It consists of consecutive segments that were initially created, and consists of the number of documents that we want, that matches exactly the number of documents in the segment, in the corresponding segment in the main index. So this sidecar merge policy takes care of that. It manages these merges so that the final number of documents per segment reaches the same targets as retrieved from the main index. As I said, the sidecar index reader unfortunately cannot extend from parallel reader, so it reimplements the logic inside. And the reason for this is that Solr really needs access to the directory. Why? Well, there are many reasons, but the main reason is that that's the way Solr handles replication. It needs to examine different index commit points and open them directly from the directory without interfering with already opened index readers. So, briefly about replication. If you have a cluster that's like a Solr cloud cluster, where index is sharded and you have replicas of shards on different machines, then of course the index commit point that is taken from the main index doesn't know anything about the data in the sidecar index. So the data that is being replicated to other replicas, they are of course stripped of all this sidecar index data. So basically, each replica has to rebuild this sidecar index locally from the sidecar collection data. But if you manage carefully how you route documents and how you allocate shards to the nodes in the cluster, then you can pretty much guarantee that the data is available locally on the same instance of Solr. As I mentioned, the implementation of reopen avoids rebuilding unmodified segments, and it uses the sidecar index reader factory for the full rebuild, which is unfortunately sometimes necessary. For example, if there was a major merge event on the main index, then the composition of the main index is completely different. Instead of segments 0, 1, 2, suddenly you have only one large segment 3, which doesn't match any of the existing segments in the sidecar index. So basically you have to rebuild the sidecar index from scratch in that case. Let me just say that while I was working on this code, the ref counting of index readers at these different levels, at the Lucene level, Solr level, and parallel reader levels, is extremely tricky. And I've been running into very strange situations when suddenly some of these segment readers would be closed and, under my feet. I must confess, I'm not 100% sure I solved all the cases. So the code is still somewhat buggy. How to use these components? Well, if you go to this link that I showed you before, you can compile this stuff. You can create a jar. You can drop this jar into Solr lib directory, and then you can simply specify that index reader factory uses this class. And in parameters in this component, you specify that the doc ID field for that foreign collection, for the Sidecar collection, is ID. And the source collection where you want to that is the source of these additional Sidecar data is called source, and you can enable or disable this Sidecar functionality. So, what is the example use case? Well, one use case that we had to handle at LucidWorks was that we are doing click-through analysis. So we are getting click-through data, which in form of logs. This user clicked on that document in response to that query, and this is a lot of data, very interesting data. It's more or less it follows this form that you have a query timestamp, document ID that was clicked by the user, the click-through timestamp when this click-through event happened, and some other potentially some other properties of this event. Then this raw click-through data is periodically aggregated, and once it's aggregated, we would like to apply it to the main index, right, without actually reindexing everything. So that's exactly the perfect use case for this split of concerns. So, for example, we would like to use this aggregated data to generate popularity score, which is probably some function of the number of clicks and the timing of clicks generated by users. Fortunately, this use case can be now handled with numeric updates. When it comes to user-generated labels that we would like to extract from this aggregated data, this could be a function, some sort of function of top n queries or phrases from these queries, interesting phrases from these queries that ended up in this particular document being selected by user, right? So implicitly, we could say that, okay, this attaches certain common concepts from queries to this particular document. And this use case precisely requires that we are able to modify documents and add full-text searchable labels. Of course, you can do many other interesting things with click-through logs. So now, once you have these searchable labels attached dynamically to the main contents, then you can expand your queries to cover also these additional fields. And then you can get some score contributions related to TF-IDF matching on those fields, right? Sounds pretty useful. You may wonder what is the scalability and performance of this solution. Of course, our dream is that with minor effort, we could turn our bike or motorbike into a Lamborghini. The reality is, of course, different. As I mentioned before, this initial full rebuild and periodic full rebuild afterwards is very, very costly. In my tests on a mid-level laptop, let's say, it takes roughly 600 microseconds to look up the primary key and retrieve relatively few and simple fields from this Sidecar collection. This may not sound like much, but if you have 1 million documents, the math says that it's going to take roughly 10 minutes to rebuild this Sidecar index. So it's not even close, not nearly close to real-time operation, right? Of course, this is for the initial rebuild and for the major rebuild that occurs after a major merge in this main index. These incremental updates, incremental segments that we have to add to the sidecar index, of course, take much less time to create. So you may wonder whether it's worth it. I cannot answer this question. It was worth to us in our use case. It may be worth to you. The advantage of this is that even with, if you pay this cost of these major rebuilds, the search time cost is negligible. Parallel reader is really, really efficient. So it's nearly impossible to tell that the data really resides in two different indexes. Some caveats. Of course, as I mentioned, this combination of ref counting at these different levels is a nightmare. I'm pretty familiar with Lucene and Solr source code, but I don't feel like I'm an expert on this. So there are certainly bugs in the implementation, and sometimes this code explodes. The telltale is that you get an exception that some of the sub-readers are already closed. And as I said before, the performance of this full rebuild quickly becomes the bottleneck on frequent updates. But it's still, the main use case for this, at least in our use case, was that you have massive updates that touch basically every document in the collection. But this aggregation that we perform on click-through events is relatively infrequent. So you can pay this cost like once a day, perhaps. The code is there. It's Apache license, so fixes and contributions are welcome. So that's the stuff basically that I wanted to cover. What are the different ways to address this challenge of applying in small incremental updates, but that affect many documents in your index. And are there any questions? Maybe one question at a time, and then you can continue with the other questions. So the question was whether we would like to update our click-through framework, or click framework as it's called in the marketing materials, to use full text updatable fields, right? Or the numeric dog values updates. Well, we would love to, of course. But currently the functionality of this sidecar index reader is a superset of numeric dog values, actually, because what we need are searchable labels, user-generated labels. So this means that we need to add fields that are, full text fields, inverted fields. And numeric dog values cover only one part of this use case, which is maybe the factors related to popularity, right? Certainly, we could handle this via numeric updates, numeric dog value updates. But the other part that this has to deal with full text searchable fields, and numeric dog values obviously don't handle it in this case. And the other question was? Okay, great, thanks. Maybe use the mic because they're recording this, so I won't have to repeat the question. Okay, I can repeat the question.
Yeah. Check. Okay, so I just wanted to clarify, did you see any effect on the performance of reindexing as far as the main index, or is it only the sidecar index that's slow?
Well, of course, this will affect the indexing in the main index, because at some point you have to reopen the index in order to make these documents searchable, right? So as soon as you reopen, then of course either this minor build-up happens that needs to create these additional sidecar segments, or a major rebuild occurs. So of course this will affect the indexing path as well. It depends on how many documents you buffer in the index writer, and how, on merge factors and a range of other factors.
So my apologies if the question is dumb, but have you? So I understand that part of the problem was to add text to existing documents.
Yes, without reindexing all documents in the main index. That was the challenge.
Would it have been possible to use grouping and collapsing to handle this?
I think this functionality is not relevant to this use case.
Okay, could you elaborate on this?
Well, as I said, the challenge was that we wanted to add additional information, additional fields to the main content of documents. So I don't really see how it's how it's related to grouping in.
Well, suppose you instead of updating documents, you add new documents with the same key, the same collapsing key, with the new text in it, and that.
Okay.
And that then you produce a group, which will function, and the scroll function will be a function of all the elements within the group.
That's an interesting idea. Maybe.
Okay.
Thank you.
And what about the join functionality? Query time.
The join functionality, as I understand it, it's more like it works like more like an inner query. So I don't know if it can pull stuff from actually join fields of fields from documents that you join from and to.
You can't retrieve the field content, the fields.
Right. I may be mistaken, but that's my understanding.
Hi. I wonder if you considered writing to both indexes in parallel and deleting in parallel and so on to avoid the need to come afterwards and synchronize? I don't know how that would work, but just a thought.
That would be all good and well, but assuming that you already have this information at the same time and you can actually, index it in parallel. Our use case was that these additional parts of the documents become available at a completely different schedule than the main content of the documents. So we could not synchronize these two activities.
Yeah, I see. Sorry. Yep, makes sense.
If you have the existing segments that are already there, could you not rebuild the documents that haven't changed from, instead of having to rebuild every document, you already have the pieces of the documents that are already in the sidecar index rebuild. You don't have to rebuild them all from scratch.
Right, source. Exactly. That's one of the slides showed this optimization that we don't rebuild segments that haven't changed. That's already contained.
Not even segments that haven't changed, but documents within segments that haven't changed. You already have the information there, so you don't have to go and do the lookup in the other index to pull the content back. You already have the content from the previous segment. So if you're merging or pulling it from somewhere else, you don't even have to do that crazy lookup. Yeah.
That's an interesting idea as well. Yeah. Feel free to contribute a patch.
Yeah, sure.
That's how it works.
Hi, just as an additional thing, really, a slightly crazy thing we came up with for updatable values using Lucene codecs. I don't know if you remember this.
Yes, actually, I presented. I talked about this. I think last year. That was conceptually. This is a very similar to the code that exists in this Lucene issue 40 something, right? The idea was to use the codec magic to create overlays or stacks of information from different segments and put this information on top so that it sort of overshadows information in the existing segments. So, as I understand, that's still the primary idea behind this implementation. That is a work in progress.
Yeah,
very much.
Yeah. We did something a bit mad with that. We made a codec that used a Redis data store to store a field. So you could go and update Redis, and Lucene hopefully wouldn't notice.
Okay, but that's that covers stored fields only, right? Not inverted fields.
Yeah.
Yeah, which is still something. Okay, thank you very much.